Shocking news! China discovers an energy source that can provide free electricity for 60,000 years, officially starting the rare earth war. Dear viewers, the world is about to face an unprecedented energy revolution, as many assessments suggest. A recent shocking discovery from China has the potential to change everything forever. Imagine an energy source that is cleaner, safer, and even more powerful than uranium. A silvery metal with the potential to provide free electricity for all of humanity for 60,000 years. If this happens, not only the economy but also the global power order will completely change. But is this a blessing for humanity, or will it be the trigger for a new brutal war? When the value of this resource is revealed, will the superpowers stand by and watch without taking action? Believe me, once this event unfolds, it will surely astonish the entire world. For over a century, humanity has witnessed countless wars erupt solely due to fossil fuels. Economies severely damaged by the energy crisis, while nations remain bound by heavy reliance on unstable resources. But deep within China's soil, the answer to this problem has always been waiting. That is thorium, a silvery white metallic element forgotten for decades, yet possessing superior energy potential. Thorium can produce 200 times more energy than uranium and operates without the risk of reactor core meltdown. And generates only a very small amount of radioactive waste compared to conventional reactors. A groundbreaking discovery occurred when China found a massive thorium deposit at the Bayan Obo mining area. In Inner Mongolia, the reserves are large enough to meet the nation's energy needs for an almost infinite period. This radioactive sensitive element can be applied to develop molten-salt reactors. A new nuclear technology with the potential to generate enormous energy. Not stopping there, researchers have also mapped a total of 233 thorium star zones spread across China's territory, forming a solid energy shield, ensuring the nation's strong rise as a global energy superpower. The most compelling argument for using thorium is its superior efficiency as fuel in nuclear reactors. When introduced into a reactor, thorium undergoes a special process called nuclear transmutation, where it converts into uranium-233. A fuel capable of producing many times more energy than conventional uranium fuel. This means the same amount of fuel, but thorium reactors generate significantly greater output, helping to maximize resource utilization efficiently, avoiding waste. Not only operating more efficiently, thorium reactors also have the major advantage of producing significantly less radioactive waste. One of the biggest challenges in the nuclear energy industry is handling radioactive waste, which takes thousands of years to decay. However, with thorium, the waste generated is less and has a shorter half-life, significantly reducing disposal and storage burdens. Especially, thorium reactor systems are designed with superior safety. If the temperature exceeds the allowed limit, the reaction automatically slows or stops entirely, eliminating the risk of explosion or sudden heat surge, which was once the cause of severe nuclear disasters like Chernobyl or Fukushima. Another advantage of thorium is that it cannot be used to make nuclear weapons, while uranium and plutonium still pose this risk, causing concern for many. Therefore, using thorium as fuel will help limit the risk of nuclear weapons proliferation, opening a new, safer development direction for the global nuclear power industry. However, despite possessing many superior advantages, thorium has not yet been widely applied in practice. The main reason comes from the global nuclear industry having invested tens of trillions into uranium technology. Transitioning to thorium use becomes complex and requires high costs. Additionally, investment capital for thorium technology research and development is still quite limited. This technology therefore cannot be commercialized on a large scale. Currently, as the demand for a clean, safe, and sustainable energy source becomes increasingly urgent, many countries worldwide, especially China, have been and are accelerating research and testing of various reactors. Thorium reaction development is progressing rapidly. One of the most advanced designs of this technology is the molten-salt reactor, MSR. Instead of using fuel rods made from cassava as in conventional reactors, Thorium is fully dissolved in molten salt, operating at atmospheric pressure. This completely eliminates the risk of explosion caused by high pressure. Especially, the system is equipped with an automatic safety plug made of solidified salt, which activates when the temperature exceeds the allowed limit. This plug will melt and push the fuel into a safe chamber, helping to prevent incidents naturally, without needing to use complex cooling systems. Additionally, thorium possesses superior advantages such as abundant natural reserves and flexible applicability in most types of reactors. It helps consume less fuel, thereby significantly reducing operating costs. In the context of many countries striving to find energy sources that are both powerful and environmentally friendly, thorium reactor technology is gradually shaping up to be a revolutionary solution. It could shape the future of the nuclear energy industry towards being cleaner and more efficient. Since the mid-20th century, uranium has been the primary fuel for nuclear reactors. This is largely because it can be used to produce gas and is compatible with existing infrastructure. However, uranium reactions reveal many serious drawbacks, from the risk of core meltdowns to other issues. Thorium produces less radioactive waste, and its lifespan is much shorter, only a few hundred years instead of thousands like traditional fuels. Therefore, it is considered much safer. Operating at lower pressure, the use of liquid fuel helps minimize the risk of accidents. More importantly, waste from thorium reactors has significantly lower radioactivity. Its decay time is shorter, and it is estimated to reduce radioactive waste by up to 90% compared to uranium. In terms of efficiency, thorium is far superior. Just 1 ton of thorium can produce an equivalent amount of energy. For the same energy output, a nuclear reactor requires about 5,000 tons of uranium, while a thermal power plant must burn 60 million tons of coal. Meanwhile, uranium reactions. Traditionally, only a small portion of the fuel is used, with the rest turning into waste, causing significant wastage. Due to its high efficiency, thorium reactors require less frequent refueling. This significantly reduces long-term operating costs and opens up opportunities for broader application. Currently, as energy security and nuclear waste disposal issues become increasingly urgent and widely concerning, more and more countries worldwide are focusing on researching and developing thorium energy. In this promising field, China is seen as a leading nation, with the ambition to become the first country in the world to successfully develop large-scale thorium reactors. This not only helps China ensure a stable long-term energy supply, but also strengthens its leading position in the global energy race. Historically, resources like oil, gas, or uranium have held key positions. Geopolitical struggles have created fierce competition among major powers. Now, thorium could become a game-changer, especially as China continuously develops this technology. This technology could even be exported to countries lacking energy resources, a scenario where China holds negotiating power on par with oil-exporting nations. Meanwhile, many Western countries are still struggling to find a path amid energy policy debates and outdated infrastructure systems. China's thorium development policy not only marks a significant leap in the energy sector but is also an important strategy. An important strategy to reduce dependence on resources controlled by the West. Currently, most countries worldwide still need to import uranium from Australia, Canada, and Kazakhstan to meet operational demands. Nuclear reactors. This not only raises supply concerns but also increases. However, China is gradually breaking free from these geopolitical tensions. With massive thorium reserves and advanced reactor technology, this land could achieve energy independence in the future. Once that becomes reality, China will no longer to ensure energy security, without relying on imported oil, uranium, or gas from abroad. A level of energy security that few countries achieve. The impact of this progress is not limited to China's borders. For over a century, fossil fuels have been the root cause of wars, economic disputes, and political alliances. Politics is a complex field. Major powers constantly manipulate markets and control key trade routes. Oil and gas have even led people to overthrow governments just to protect their interests. But thorium could completely change the landscape. Unlike oil or uranium, resources that can be manipulated, thorium is found in many places worldwide and is difficult to monopolize. When thorium reactor technology reaches commercial scale, the strategic value of this fuel will be further affirmed. Reconciliation could achieve significant progress, leading to reduced tensions between nations. Oil and gas. Once energy is no longer a reason for disputes. Instead of confrontation, the world could enter an era of cooperation. Of course, thorium cannot completely eliminate all global conflicts. But it has the potential to fundamentally change how countries approach energy issues, instead of racing to control oil fields or gas pipelines. A country could dominate and direct the flow of energy. Technological innovation and sustainable development. If these solutions are widely implemented, thorium not only contributes to environmental protection but also has the potential to lay the foundation for a sustainable energy future. Towards a world where energy is no longer a cause of war. China has officially commenced construction of the world's first commercial molten-salt thorium reactor. With the initial testing phase completed, the plan will be fully implemented in the coming years. The country is pursuing an ambitious vision, creating smart and efficiently operated cities. Fully utilizing thorium energy, gradually replacing thermal power plants, and providing a clean, stable power supply for urban development. This is a crucial part of the overall plan to achieve carbon neutrality goals. Since the 1960s, they have gradually risen to become a leading power in future energy technology. Compared to traditional uranium-based nuclear reactors, thorium technology possesses many superior advantages. Moreover, thorium reactors are not only safer but can also be built in densely populated areas. This energy source poses almost no significant radiation risks. This is a major advantage for a vast and rapidly urbanizing country like China. Developing thorium-based reactor modules will enable cities to produce and consume electricity locally, no longer relying on energy sources that must be transported from afar, such as coal-fired or hydroelectric power. This not only reduces power loss but also ensures stable electricity supply even for remote areas where the national grid is hard to reach. Not stopping there, China also plans to apply thorium energy in transportation and industry, progressing step by step towards an economy powered by clean energy. If successful, this model could become a template for other countries to follow. When thorium technology is widely developed at a reasonable cost, it has the potential to revolutionize the energy industry. The world is forced to consider transitioning, or else it will have to accept dependence on China in this field. Meanwhile, with its rapid development pace, China is likely to be the first country to set new standards for next-generation nuclear energy. Meanwhile, Western countries are still struggling to overcome policy and infrastructure barriers. In contrast to the situation in China, Western countries like the US and European nations are facing significant difficulties in keeping up with this trend. For a long time, they have focused on developing uranium reactors and building entire systems around this fuel type. To switch to thorium, they would have to completely redesign the reactors. The fuel processing procedure must meet strict safety standards. This is an extremely complex and costly process. Moreover, politics and public opinion are also significant obstacles. Disasters like Chernobyl or Fukushima remain haunting memories to this day. Western people are therefore wary of any nuclear technology, even though thorium has superior safety features. Additionally, pressure from environmental organizations is another reason why Western governments hesitate and delay. Investing in nuclear energy is not enough. They need to focus more on renewable energy sources, such as wind power. Although in reality, solar power currently cannot fully meet global electricity demand. Disputes over energy policy have caused the West to fall behind in this technological race. Meanwhile, China is advancing further. If this trend continues, China is very likely to become the leading country. In the field of next-generation nuclear energy technology, this will not only change the global energy industry. This race is not just about technological development but also has the potential to shift the balance of power among nations in the 21st century. The West risks losing the key energy transition race of the 21st century. Although some private companies and research institutes in Europe and the US have begun developing energy technology, however, they are not receiving strong support from their governments. Meanwhile, China is also investing heavily, dedicating significant resources to research and application. Thorium opens a new direction for the nuclear energy industry. This is a change that must be urgently implemented. Western countries may become dependent on China in the field of advanced nuclear technology, something that could completely change the global energy landscape in the coming decades. The West needs to wake up in time. If they do not want to be left behind, Western governments must act. This action aims to increase investment in thorium research, supporting new technology